Introducing GP-JAMA, the industry's first true multi-channel software-defined JAMA simulator. This Windows application operates with the popular SDR from analog devices, enabling researchers to simulate wideband interference for testing communication and navigation system resilience against jamming. The first killer feature of GP-JAMA is true multi-channel capability. This means you can connect and use an unlimited number of SDRs to create a highly wideband and complex interference environment. Killer feature number 2. With our custom firmware, this affordable SDR can generate RF signals across a frequency range from 70 MHz to 6 GHz with a maximum IQ rate of 56 MHz. It's enough to test virtually any communication on navigation system. Let's see how it works. Here you can see a dashboard with 3 SDRs connected. The generation of RF signals can be started simultaneously or one by one. Each channel can be individually configured to any desired modulation, central frequency, and output power. Let's configure one channel. Here is the interference library that comes with the software. All you need to do is choose the desired jamming type, configure it, and press the play button. The library includes simple modulations like pulse, chirp, and Gaussian noise, but we also have more advanced options such as chirp combined with Gaussian noise or Gaussian noise with pulse modulation and a pseudo-random repetition interval. This is my personal favorite, Gaussian noise with pulse modulation and frequency hopping. Each impulse is generated on its own pseudo-random central frequency. Let's see how it works. To evaluate jamming performance, we use our GNSS interference detection system. Here you can see GP Cloud user interface and live data coming from one of my probe. Let's go. Our system immediately detects the jamming signal. On the spectrum waterfall, we clearly see the interference. Look how amazing the signal looks on the spectrogram. Here we come to killer feature number 3. All these interference signals are created using Python, and the code is fully available to you for analysis, modification, or even creation of your own complex modulation types. This flexibility is more important than ever. A fair race is underway between manufacturers of communication equipment and jamming systems. This is especially evident in the drone and anti-drone industries. Being prepared for these scenarios in advance is absolutely critical. In the GNSS folder, you can find 3 examples of sophisticated interference specifically designed for GPS. These signals mimic the structure of GPS signals and are quite similar to spoofing. This type of interference is often called matched spectrum jamming and is intended for advanced users with expertise in digital signal processing. Why multiband capability is really important. For testing a multiband GNSS receiver, you need just 3 channels, one for each band, L1, L2, and L5. When testing a drone, you will need at least 3 additional channels to jam control signals, telemetry, and the video link. For testing advanced anti-jamming antenna systems like CRPA with beamforming or null steering technology, you may require dozens of distributed interference sources to accurately simulate real-world conditions. You might be thinking, what's the problem here? Well, there isn't one. If you have an unlimited budget, you could simply buy the required number of RF signal generators, but it's going to be expensive. With GP-JAMA, every additional channel costs just $250, making it a true game changer in the industry. Thanks for watching. Don't forget to subscribe. Next time I will show you how to test a multi-band GNSS receiver from Septentrio.